Ganpati. Now in probability we'll move into the problem number 5 today. So to start with, the problem that will come as 5, it says a dice is thrown, a dice is thrown once, so you have to find the probability for following cases where we need to have prime number as a result. Okay, and second, the number divisible by 2. So in other way, this can also be said as even number. Okay, this is not in the question, but if it is such that if it is divisible by 2, it must be an even number. So let's start. So to start with, as I already described what is prime number and why 1 is excluded from being a prime number is that I have explained. I need not to repeat it again, but when you see the numbers in the dice, that comes as 1, 2, 3, 4, 5 and 6. These are the 6 possible result may arise if you toss a dice or if you throw a dice. So the prime number of it is 2, 3 and 5. So probability of getting prime number when you throw a dice, or total, the sample space is 6, so that is possible outcome is 6. Whatever you throw, you will get a number, that is, and that case you get only one number. You won't get two numbers together or more than one number together. So you will get 6 individual results. So possible results is 6, and the prime number that you will get is 3. Out of this, if this result comes, then you can only say that is got a prime number. So ultimately this will become half. This is first one. Second one, to get even number, I name it an even number or divisible by 2. If you represent this is again how many number? 2, 4 and 6 are the number that is divisible by 2. So the numerator will hold 3 out of the possibility 6. So you will get half as a probability. Okay. So next we will move to the problem number 6. So problem number 6 is, it is known that a box of 1600 electric bulbs contain 80 bulbs, 80 defective bulbs, 80 defective bulbs. Okay, one bulb is taken out at random from this box. Now you have to find probability that it is non-defective bulb. Okay, So when you start doing any problem, the requirement you have to understand first. It's not that every problem would be said directly what is being needed. There could be possibility that it needs something out of our regular expectation. Now, if you read it out, the first part of that, and don't concentrate on the second part, you can make a mistake. It is known that a box of 1600 electric bulbs contains 80 defective bulbs. One bulb is taken at random from the box. What is the probability? Now, if this is a flow, that you always has an impression that probability of getting how much of defective bulbs. So there you could make mistake, because this has been twisted here, non-defective bulbs. So okay, so what is your probability of getting defective bulbs? There is 80 bulbs which is defective, and out of 1600 bulbs, so this would be the defective. So if it is non-defective, what will be my result? Isn't it? We have learned it, because probability of happening and non-happening. This is non-happening. Probability of non-defective bulbs. This is happening, defective bulbs. If we pull, there is a chance of getting defective bulbs. This is happening. So happening plus non-happening together for any event, it is equal to 1. That we have learned. So if it is defective, is this one. Defective means 80 numbers of defective can be possible. If we drag one, there is a chances of 80 numbers out of the possibilities. Total possible is 1600. So if you reduce it, this is almost 1 by 20. So getting non-defective probability will be 1 minus 1 by 20. So that means 19 by 20. So this is one way of doing. Or else, what is, if it is 80 defective, the non-defective is bulb is how much? 1600 total minus 80, you will get how much? 1520. So probability of non-defective bulbs straight away you can find by doing this. In this case also you would get the same result, 19 by 20. Okay, there is no harm in it. So as we learned in some theory, it is better to use that. It is always correct also, but it is always better what you have learned you are implementing or you are putting in application. Okay. So moving to next, number 7. A box contains 50 balls of the same shape and weight, of same shape and weight. Okay. Among the balls, 10 balls are white, 15 are red, and rest are black. A ball is randomly drawn. A ball is randomly drawn from the bag Okay, find the probability that the ball drawn is, you need to calculate three items. One, when you will get white as a result, when either of black or white, or black or red you will get as a result, and when you will get not black. So this is very bit interesting. Not black means what? Not happening. When something is added with not, that means you are asking for not happening. It is getting black is happening, this is not happening. Okay, so you must have got the hint what I meant to say that. Okay, so here total number of sample space is 50. So 50 consists of how many of balls? 10 are white, 10 white ball. How many of red? 15 red. So in this case the rest is said to be black. So from that equation, how much you will put in black? The equation is 50, 10 and 15 already gone, so it must be 25. You need not to do any other arithmetic on all that. That is but bit clear from this equation. So you can put definitely 25 for the black. So this is clear. Now for first one, when you will calculate for white, what is your white count? 10. What is your total possibility? 50. So this is 1 by 5. For second, when you are getting either of black or red. So if you want to get either of black or red, but not in any sequence, so whether you pull it, you will when you pull a ball, you will get black, that also accepted. When you pull a ball, you get red, that also accepted. So both the numbers together will have the possibility to get. So your count will be on the numerator. What do you want to get? Black 25 and red 50. So all total 40. Out of the count is same, total count is same, so 4 by 5 is your second result. What is your third result? Probability of happening is how much? Probability of happening is how much? Black is how much? 25. Probability of happening 25 out of 50. So this is half. So probability of not happening is 1 minus half, that is equal to half. Or else other way you can calculate. If it is black is 25, the rest is not black. So if it is not black is 25 also. So the probability of not getting black is 25 upon 50. That way also you will get half. So that is that process also true if you do like that. Not black out of 50 is 25. Other color. So other color, that means not happening of black. That way directly you can get the results. Okay. That also possible. So we'll move to the next problem, number 8. Next is your number 8. So number 8 is 3 coins are tossed at a time. Find the probability of getting want two heads to at least two heads, third at most two heads. So to solve it, first what we have to look at, earlier during the discussion of theory we have explained tossing a coin once, tossing two coins at a time, or tossing a coin consecutively. That result we have described. Now in this case the tossing of the coin comes thrice. Okay, so if I look at it like that, what are the combination of tossing a coin? If I say head, one side 3 coin, other side tail. So the combination could be the way the 3 can be possible, means the tail can go with this 3 coin, so tail can be adjusted this way. It may not be possible to counter it. Let's see, we go for the options first. The first option for coin, head, second head, third head. Let me go like that. Then I will not change the first and second initially. I will take a tail of the third possible. Second case I will change the second and third together. Third case I will take the all tail. Now I have changed the total program. Now slowly I will change to tail. This could be head, this could be head. Now tail, head, tail. So this total transformation. Then tail, head, tail, head. Then tail, head, tail, head we have not taken yet. The extreme is head and head. Now the next can be, the extreme are tail and head. So this is 1, 2, 3, 4, 5, 6, 7, 8. Any other possible? We have taken all head, all tail, taken extreme head, tail, extreme tail, head. This tail, head also taken, head, tail have taken. So we have transformed up to this. Then again tail, head have taken, tail, head have taken, head, tail, tail. So this could be the all possibilities. Okay, any other possibilities may not be possible. Okay, fine. Now we'll do the first one. What it says, two heads. Now two heads, and the next one is at least two heads. That means at least two heads means the number of head possibilities 3, at least 2, that means between 3 and 2 we have to choose. The third one is at most 2, so that means 2, 1 and 0. This will be the choice. Second case, at least 2 means 3 is possible because least is 2, maximum is 3, and at most 2 means least could be 0, and in this case getting 2 means definite 2 heads only So neither you can cross 2 or either side, means you cannot go above or below 2 wherever 2 is. So the result where 2 is possible, we will talk about the first case. 2 is here, 2 head is here, this is possible 2 head. So these are 1, 2 and 3. So your probability of getting 2 heads is only 3 out of 8. This is the probability. Second case, already described, the least 2 heads, that means 3 and 2. So this is 3 head and other 2 already have counted here. So 3 is definitely with there. You won't get any other double 2. So only thing you have to add where 3 heads is possible. So your probability will change where more than 2 head, that we can say more than 2 head, because least is 2, more than 2 head is 4 out of 8, that means half, isn't it? And the third case, you get probability of less than equal to 2 head, and this is greater than equal to, okay, that I have to. So how many? You cannot cross 2 head, so this 3 is definitely be there. Along with that, when 1 is there, this 1, this 3 plus 4, 5 and 6. 6 numbers out of 8. So this is 2 upon 3. 2, 3, 4. 3 by 4. Sorry, 3 by 4. This will be the probability. Understood? So first you have to bring it like that. I have tried to do it putting in matrix, but that is not serving my purpose. You individually take the change and completely transform, then other possibilities you have to check. But this is very important. If you miss one, then your result will definitely affect. So how do you do that? Or otherwise, the probability, as I said, when options are coming and, means this and this and all and are coming, means these are the possibilities. When you are tossing a coin, you are getting head tail head, okay. These are the possible means when you are tossing one coin, there is a probability of getting 2 possibilities. So the possibilities, if I say possibility outcome is 2 into 2 into 2, because one single event is like getting 2 results, possible outcomes. So that 2 along with the similar event, if it is done, it will be multiplied, as because you are doing one coin tossing and the second coin tossing. When and is coming, initially I said when or is coming, you have to add the result. When and is coming, you have to multiply with the result. So tossing first coin and tossing second coin and tossing third coin, or else tossing all 3 coins together, that have the same meaning, and where the multiplication of the possible results has to be needed to get the complete possibility. So in this way, either you can do it physically or you can get the result by multiplying the possible results of each event, because these are being done. First coin tossing and second coin tossing, all cumulative result you want to get, not or first coin or second coin or third coin, like that will not say. We'll say first coin tossing and second coin tossing and third coin tossing, cumulative result, how much possible outcomes is possible. So in that case, coin tossing is always a 2 possibilities for single coin, second coin will multiply by 2, third coin. So this is 8 possibilities. Now in this case, you can fix a theory when the number of coins changes every time, you have to multiply 2 to get possible results. Now why this is needed? This is needed to get the favorable outcome, that is how many heads, how many tests. For that, once you can get that outline, that then you definitely will see whether something is missing or not. Now here, once I get the number will be 8, you definitely will see if I miss something, I will try to get that. So there is a chance of cross checking your result. Okay, so with this I will end. I will start the next problem in next episode, number 9 and onwards. So thank you for now.